Hi there, my name is Zora. I'm an indie game programmer, and this is a demonstration of computer graphics techniques in Unreal Engine 5.3. This is my first Unreal Engine project, and I'm here to talk you through what I've made. This project has two parts. First, game setup, and second, the game itself. This screen is the game setup, which is a technical demonstration of implementing a two-dimensional user interface which offers the player choices about the appearance of the game before they start playing. The demonstration game itself is a first-person shooter. On the right side of the screen, you can see an example of the appearance of enemies in the game. What we're going to be configuring here in part 1 is the appearance of your adversaries in the game, because their colors change depending on their behavior. In order from left to right, you can see buttons for each of the 3 behaviors which the enemy characters will exhibit while you play the game: idling, investigating, and hostile. At each moment during play, each enemy in the game will make choices about which behavior to exhibit, depending on the actions of the player. By default, they will be idle. If you fire your weapon but they cannot see you, they will move to where they heard the shot to investigate. If they spot you, they will relentlessly pursue you with the hostile behavior. Clicking each of these behavior buttons changes the appearance of the character on the right-hand side of the screen, showing you the default appearance that I have chosen for each of the behaviors of the enemies: green for idle, yellow for investigating, and red for hostile. The next 2 buttons each represent a cluster of body parts which are grouped together and share a single color. Here is where we get to the player's choices. For each behavior, the player can select a color for each of the groups of body parts. Once we start the game, the enemies will remember your choices here, and when they enter each behavior state, they will color themselves according to your choices. For example, let's set the idle behavior to be green and blue, the investigating behavior to be blue and yellow, and the hostile behavior to be yellow and red. There are a couple of things I want to point out about this windowed view of our enemy. We're able to view this little guy at the same time as we can see the rest of our user interface, because the user interface is making use of a render target connected to the view of a camera in the scene. What that essentially means is that we're able to see multiple camera views simultaneously. The game is actually paused right now because we haven't hit start. Nothing is happening in the background yet, but this little guy is animating because they're the one character in the scene that I've permitted to act even while the game is paused. Let's take advantage of that with these 3 buttons here. These 3 buttons, labeled idle, walk, and run, are 3 discrete animations which will play when we click each of these buttons. The default animation is idle. These 3 animations, idle, walk, and run, are connected together by an animation blend space, which means that when I click each one, the character demo smoothly interpolates between them over a period of time that I choose, rather than instantaneously snapping from one animation to the other. If we put all that together, this demonstration lets you select the behaviors and their colors of the enemies you'll be competing against in each moment. You can select 2 colors for each behavior state, with each color being applied to a specific collection of body parts. You might have noticed that our little guy on the right has a yellowy orange outline. If you're eagle-eyed and familiar with Unreal Engine, you'll also have noticed that this stock character is being illuminated in a way that isn't standard. Just before we start the game, I'm going to quickly talk you through two visual effects that I've applied to this project. Both effects are post-processing shaders. If you're unfamiliar with post-processing, I'll give a quick rundown of what I've done here at a conceptual level. If you assume that your screen is refreshing at about 60 times a second, that's analogous to the game engine showing you 60 photographs. Imagine that a frame is an individual static image, layered on top of others so quickly that it looks like motion. Now, every time the game engine prints out one of those images, destined for your monitor, that means it calculated the position of everything in the scene, took account of all the motion, all the physics, and everything else that's happening, and it predicted where everything should be. You can imagine our post-processing effects as a rule that we've written for the game engine to follow, but they're only applied after the game engine has taken each photo, but before they've sent them to the monitor. We've intercepted that image and we've edited it before sending it on its way to the screen. By doing that, I've added not just an outline to our enemies, but to other objects in the scene as well, which visually assist with understanding the game at a glance. That's why, no matter what color you pick for the enemies to be here, they'll still have an orange outline. I've set this effect up so that every single enemy could have its own unique color, but right now they'll all be orange. The second effect is what's called a toon shader or cartoon shader. As a post-processing effect, this shader takes the image that would otherwise have gone straight to the screen, and it reduces the smoothness of all of the colors, creating a comparatively hard line at the point where colored objects transition from being illuminated to being in shadow. This produces an effect where the world looks to be built of larger single blocks of colors rather than lots of smooth gradients. A very strong example of this effect can often be seen in anime. Alright, now that we've picked the colors of our enemies, let's play the game. Let's start by picking up the weapon in the scene and having a wander around. We don't need to worry too much about our enemies. This is just a demo after all. At all times, the enemies in the level are making decisions about what they want to do. If they don't know what to do, they wander to a random point in the level idly. If they can't see you, but they hear you shooting, they'll come have a look in the investigate state. Once they see you though, they'll never stop chasing you. You can see right away that our post-processing shader is visually identifying a couple of different things in the scene here for you. Enemies are outlined in an orangey yellow, as we said before. But there are some little green things around the level, and big blue boxes. The big blue boxes, as you can see, are just bouncy boxes that you can shoot and move around the level. I picked them out in blue to draw attention to them because they're neither positive nor negative, they're just a point of interest. If you look in the top right, you can see we've run out of ammunition, so we can't defend ourselves anymore. When we walk over the top of these green cylinders though, highlighted for us by the post-processing shader, we get more ammo and can fire again. If I hold down the right mouse button, I can zoom in, and if I hold down the shift key, I can sprint around the level, momentarily depleting my stamina, as you can see in the top middle of the screen. Stamina, unlike health or ammo, replenishes by itself over time. If the top middle of the screen, you can see that you have a health bar, and each time the enemies get close enough to you, they'll attack you and take away some of your health. Once they hit you enough, that's game over, and it's time to start again. Just like that. Let's try that again. Let's pick this up, and this time you can see in the top left that we have a target. If I shoot 3 enemies enough times each, we win the round. You might also have noticed that our enemies have retained the same color choices we made at the start too. There's no complete victory in this demonstration. It simply keeps increasing in difficulty and adding 3 enemies per round. Enemies will endlessly spawn until either you've won or they've defeated you. The maximum number of enemies that can be in the game at the same time increases as you progress through levels. If I was to quit the game right now and reload it, the game remembers which round you played last and will remember where you left off. If you're a programmer and are curious about the construction of this demo, you are more than welcome to reach out to discuss it. At a high level, I've made extensive use of the observer pattern to control the game according to events bound to event dispatcher calls. I've used enumerators and interfaces to allow blueprints to communicate with one another without loading entire blueprints into memory with every exchange. The user interface is controlled by a custom head-up display blueprint with separate blueprint actor components for each user interface functionality, such as the in-game overlay for ammo, health, etc., the main menu, the pause menu, and the victory and defeat menus, all of which are dynamically created, updated, and destroyed by the HUD. I made the dynamic AI behaviors through use of Unreal Engine's behavior tree, Blackboard, and AI controller system. The save and load game functionality is run through communication between the game instance and the game mode, with the game mode controlling all of the logic for processing and progressing between rounds. The 2 post-processing effects I discussed earlier are both primarily driven by kernel sampling, using a combination of sampling from the scene color buffer, the scene depth buffer, and the scene normal buffer. I've made use of both the custom depth buffer and the stencil buffer for these effects. Thank you very much for following me through this demonstration. My name is Zora, and I'll catch you next time.